Here we have a right triangle, and I want to know the values of x and y, those two missing sides. Because it's a right triangle, I know that I can use my trig functions to find this. So TOA, I'm going to use this 23-degree angle here as my reference. So now I know that I can figure out my opposite, adjacent, and hypotenuse relative to that angle. And so the side opposite is the one side that's not making this 23-degree angle here. So that would be the 17 here. So this is my opposite side. And then the side adjacent is the side that's not the hypotenuse and not the opposite side. So this is my hypotenuse here. So that's got to be my adjacent side here. And lastly, I've got my hypotenuse. The key to this is we need to use one angle because that tells us what right triangle we're working with. Remember, all of these are just known ratios for a particular right triangle. So if we know the angle, we know the right, and we know which triangle we're working with. And then we need to use two sides. And so here we have a total of 3 variables. And if we're going to solve something with 3 variables, that means we need to know 2 of them. Well, we clearly know the angle here, so that's going to be one of them. And then we're missing these 2 sides, so I clearly wouldn't want to pick these 2 sides to work with. So I'm going to work with this side, the opposite side. And then from there, it's just picking another side. So I'll go ahead and find the adjacent side first. So I'm going to go up to my acronym here, and I know that I want to use the opposite side and the adjacent side. And so looking at that here, that's got O and H, so that's opposite and hypotenuse. This one has adjacent and tangent has opposite and adjacent in it. So I'm going to be using tangent. And so it's just tangent of the angle, and I'm using that 23-degree angle there, is equal to the opposite side, which is 17, over the adjacent side, which in this case is unknown. I'm going to go ahead and, well, now we just want to solve this. So I'm going to go ahead and put that over 1, and then I'm going to cross multiply. I tend to put most things in parentheses when I cross multiply just to avoid confusion. And then I want to isolate x. Well, I'm multiplying these out, so I'm going to use division to create a 1 here. And that leaves me with 1x, but I changed the left side of the equation, so I'm going to have to do the same thing to the right side of the equation to keep it balanced. And we wind up with the fact that x is equal to 17 divided by the tangent of 23 degrees. And that's something you can actually just put into your calculator to find the approximation. That's the most exact answer you can have. And we wind up knowing that this is approximately 40.05. So that's our full solution there for x, both the exact answer and our approximation. Again, this one's exact, but to be honest, in the real world, that's probably not going to be too useful. So it is nice to have a good approximation as well so that we can have an idea of the amount. In fact, I'll go ahead and fill that in up here just so I can look at it once I find everything. Now, here's the thing. If we want to find the hypotenuse, well, that means I'm going to have to use this side here. So I need to pick a second side. I'm going to use the same angle. I have a choice here. I can use the adjacent side or I can use the opposite side. However, keep in mind, this 40.05 is approximate. It's wrong. It is incorrect. It's off by a little bit. So if we use it, our answer is going to be off by a little bit more. So the better choice is to pick the number that we know is exact and use that opposite side again. So I need to look back up here and decide, well, which one of these trig functions is going to use the hypotenuse and the opposite side? Which one's that trig ratio? And I can see that is SO, or sine. So sine of 23 degrees is equal to the opposite side, 17, over the hypotenuse, y. I'm going to go through the same steps that I did before. So I'll cross multiply sine of 23 degrees times y. And then the other cross multiple comes out to be 17 times 1, or just 17. Then I divide by 17 over 23 to isolate y. And I'll pop that one in my calculator as well, just to get that approximation. All right, and so there I have a nice exact answer and approximation, and I'm going to throw that into my diagram as well. I'll just put the approximation up here. Now, the last thing I tend to like to do is to double check that the smallest angle is opposite the smallest side, medium angle, medium side. The biggest side should be opposite the right angle. And to do that, I need to fill in the last number here. Well, 23 plus 67, those equal 90, plus another 90 is 180. So I know this angle up here is 67 degrees. So the smallest angle is 23. Opposite it is 17, which is the smallest side. The next smallest angle is 67 degrees. Opposite it is 40.05. That's good. And then obviously the largest angle in a right triangle is always the 90-degree angle, and that is opposite the hypotenuse, which is the largest side based off of the lengths I have here. So everything seems to make sense, but you'll notice that I had to go through use two trig functions to find both those sides there, plugged them back in to make sure that they seemed reasonable.